Hi, I'm going to do a distance problem that uses the quadratic formula. So the important thing of this type to do on this type of a problem is to set up and figure out your distance, your rate, and your time. Let's read the problem. So we have Roberto drove at a constant speed in a rainstorm for 225 miles. He took a break and the rain stopped. He then drove 150 miles at a speed that was 5 miles per hour faster than his previous speed. If he drove for 8 hours, find the car's speed for each part of the trip. So to fill out this, first of all, we have to acknowledge that the formula that you're going to use is distance equals rate times time, okay? And that's a constant, that's on these type of problems, that's the formula that you always use. Okay, the distance for driving with the rain was 225 miles. And the distance for driving without rain was 150 miles. Now the rate is their speed. And the only thing we know about their speed is that with no rain, it was 5 miles per hour faster than the one with rain. So if we let x be how fast Roberto drove with rain, then we just add 5 to that without rain. So we have x and x plus 5. Now, we want to find the car's speed, but we still need to figure out what the time is, and we weren't given anything about the time except he drove for 8 hours. But we don't know the time that he spent with rain and without rain. So I'm going to just kind of keep note of that. We have the time he spent with the rain. I'm going to call it TR. And we have the time he spent without rain, T no rain, NR. Okay, just to show that they're different times. So our formulas are going to be, or our equations are 225 equals x times t, and it's the time with the rain. And we also have 150 equals the x plus 5 times t. And I'd like to use parentheses around the x plus 5 because that has to stay together. And it's the time without rain, so an NR. Okay? Now we know that if we add up the two times, they're going to give us 8 hours. So we need to use that information. So we know that the time with the rain plus the time without the rain, or NR, that's going to equal 8. So what we want to do up above is solve these equations for time. So in order to do that, I've got the x times the time, so I'm going to divide by x in this case on both sides. So we have 225 over x, and that equals, because the x's cancel, that equals the time with the rain. And then on the right equation, we're going to divide both sides by the x plus 5 to get the time by itself. So that gives me 150 divided by x plus 5. And that equals, notice the x plus 5's cancel out, and it leaves me just with the time without rain, NR. Now we're going to substitute in, so let's look at this. We know that T of R is 225 over x. So in place of this T of R, we're going to substitute in 225 over x. Okay. Now for the T of NR, we know that that equals up here this 150 over x plus 5. So in place of the t of nr, we're going to get 150 over x plus 5. And that equals 8. So what we're doing is we're adding up the 2 times to equal the 8. Now we have a rational type equation. Let me scroll down to get a little more paper here. Rational meaning that it has fractions involved. So the way we get rid of the fractions is we multiply by the common denominator. Well, I have common denominators. I have a denominator of x. That's the bottom part of the fraction. I have a denominator of x plus 5, and there's no denominator on the 8, or it's just 1, so we don't worry about that. So I'm going to multiply by the common denominator of x times x plus 5. Don't forget to put the additional x because it is not taken care of by the x plus 5. So I'm going to multiply all 3 terms or pieces of this equation by that common denominator. Even the 8. Okay? Now, what is nice about this is that things cancel out. In this first fraction, these x's cancel out. So what I'm left with is the 225 times this parenthesis. So I'm going to put the 225 first and then the parenthesis second because it's commutative. You can switch the order. On this second fraction, the x plus 5's cancel out. So I'm left with this x times 50, but we usually write it as 50x. Oh, I'm sorry, that's 150. I lost the 1 in there. There is a 1. Okay, so it's 150x. Now on the final term here, there's nothing that cancels. So I have 8x times x plus 5. Now we have a better looking equation here to solve. Not quite so difficult. So what we want to do is simplify each side. I want to get rid of the parentheses, so I'm going to distribute in the 225. So that gives me 225x plus, and then 225 times 5 is 1125. Then we have plus 150x. So that's simplified on the left. And on the right, we need to distribute in the 8x. So this gives us 8x squared plus 40x. Now, to solve this type of a problem, I want you to notice we have an x squared here. So we have to solve this using quadratics. It's a quadratic equation. And the way we do that is we get this x squared part and everything over to one side and set it equal to 0 on the other side. So I'm going to subtract everything to the 8x squared side. So I'm going to subtract and combine like terms the negative 225x and also the 150x. So I'm going to subtract 225x and the 150x. And I'm also going to subtract the 1125. Now you don't have to do this all in one step. Notice there's no like term for the 1125, so I'm just going to subtract it. I did it all in one step, but you can do each piece separately. So what that gives you is a 0 on the left side, because everything cancels. And on the right side, we have 8x squared. Then we have 40x minus 225x minus 150x. which gives us a negative 335x, and then minus 1125. Okay, you could try factoring that, but I'm just going to use the quadratic formula to solve it. It's fairly simple. So to figure out what x equals, once we've got it equal to 0, the quadratic formula is negative b plus or minus the square root of b squared minus 4 times a times c over 2a. So let's figure out what pieces are which. So our a is the number in front of the x squared. So I'm going to replace that a with that, and that a with the 8. Our b is the number in front of the x. So I'm going to replace that b and that b with it. Notice it's a negative 335. And our c is the constant. So it's right there, and I'm going to replace the c with that. So let's rewrite. So we get x equals a negative b, which is a negative 335. So you've got a double negative there. Plus or minus the square root of, and we've got the negative 335 squared minus 4 times 8, which is a, times a negative 1125. And that's all over 2 times 8. Now let's do order of operations. So I'm going to do this square here first. So negative 335 squared. That's negative 335 times negative 335 is quite large. So we get, I'm going to also do this negative 335. The double negative just gives you positive. So 335 plus or minus the square root of 112,225 minus, and now let's do this multiplication. 4 times 8 times 1125, that's a negative. So a negative 4 times 8 times a negative 1125 is a positive 36,000. And that's over 2 times 8, which is 16. Now let's add in the square root. So we get 335 plus or minus, and we add 112,225 plus 36,000. That gives us 148,225 over 16. Now let's take the square root of the 148,225. And that's 385. So we have 335 plus or minus 385 over 16. Now, when we put the plus or minus, that means there's two things going on here. That means that x can equal 335 plus 385 over 16, and x can also equal 335 minus 385 over 16. So let's simplify both of those. Let's do the first one. 335 plus 385 equals 720. And let's divide it by 16. and that's 45. Let's do the second one. We have 335 minus 385. That gives us a negative 50 divided by 16 is a negative 3.125. Okay, so what was x? X was our rate, our speed of the car up here. So one thing we need to pay attention to, you can't have a negative speed. So we're going to toss that answer out. So our x equals 45 miles per hour. And remember, that's for the speed with rain. And with no rain, it's x plus 5. So we've got 45 here, and x plus 5 equals 50. So both of the speeds are 45 and 50 miles per hour. I hope that helps.